Okay, example C. We have 7 times 9 to the negative x is equal to 2. Okay, this is an equation with x in the power, so it's an exponential equation, so we're going to try to solve for x. First thing you need to do is identify and isolate the exponential piece, okay? What is being raised to the negative x power? Well, just the 9. The 7 is outside of the parentheses, so it is not being raised to the negative x power. So the exponential piece is what's in parentheses, this guy, okay? We need to isolate that, okay, before we can take the logarithm. So since this piece, 9 to the negative x, is being multiplied by 7, to undo this, we're going to start by dividing both sides by 7. Okay, so let me rewrite the original equation here. Okay, we are going to start by dividing both sides by 7 because you've got to isolate the 9 to the negative x. Okay, all right, so we've got that. Okay, my 7s will cancel. Okay, and then that's going to leave me with 9 to the negative x is equal to 2/7. Okay, all right, so in the next step, now this guy is isolated. 9 to the negative x, the thing that has the x in the power is by itself. Now it's okay to take the logarithm of both sides, okay? Remember, it's up to you if you want to use natural log or if you want to use log, the base 10 logarithm, okay? Since in example B, I use natural log, I'll use log here. But remember, your answer, your decimal answer is going to come out the exact same, okay? All right, so I'm going to take the logarithm of both sides. I'll do log. The log of 9 to the negative x has to be equal to the log of the quantity 2/7. Okay, so what good did this do? Well, again, you've got logarithm of something to a power. Okay, so the power is going to come down in front. Okay, so we're going to get negative x times the log of 9, okay, is equal to the log of 2/7. Okay, so if you were to use your calculator, the log of 9 is going to be some decimal. The log of 2/7 is going to be some decimal. So you've got negative x times a number is equal to a number. Okay, so if you want to get x by itself, okay, we'll go ahead and solve for negative x. We're going to divide off this log of 9. Okay, whatever you do to one side, you have to do to the other. Okay, so we're going to get negative x is equal to the log of 2/7 over the log of 9. Okay, now remember, you want to solve for x, not negative x. Okay, so last step is we need to multiply both sides or divide by -1. Okay, so our final answer will be, okay, so negative times negative will give us positive x. Okay, and remember earlier in the semester we talked about how to multiply a fraction by -1. Okay, remember this is going to be over 1. Okay, you multiply across the top and across the bottom. Okay, you only change the sign of the top or of the bottom, not of both. So x is going to be the negative will go on the outside. Okay, because all you're doing, remember, log of 2/7 is just a number. You're changing its sign. So it's going to be negative log of 2/7 over the log of 9. Okay, this is the exact answer. Okay, and then we can plug it in for a decimal approximation. Okay, all right. So basically, if you had used natural log instead of log, your answer is going to look identical, except you would have ln instead of log. Okay, but regardless of which one you use, you should get the same decimal approximation. Okay, so I'll go ahead and plug in what I got. So I've got negative log of 2/7. That whole fraction you're taking the log of. Okay, and then you're dividing by the log of 9, close parentheses. Here's your answer. Okay, so the approximation is going to be 0.570 if I round to 3 decimal places. Okay, that's it for that one. Okay, so remember, I cannot emphasize enough, you need to isolate the exponential piece before you take the logarithm. All right, part D. Okay, we have 3 times e to the 2x plus 1 is equal to 15. Okay, let me rewrite this. All right, first step is identifying what is the exponential piece? What are you raising to the power? Okay, what contains the x? Okay. When you look at this left side, because the x is on the left side of the equation, the e is being raised to the power, not the 3. Read it to yourself. This is 3 times e raised to the 2x plus 1 power. Okay. Remember, e is the number 2.71 about. Okay. You don't use the decimal approximation. You just use e. Okay. So this really is a number raised to a power. Okay. Since the 3 is not raised to the power, we have to get rid of it. And we're trying to isolate this guy because only the e contains the x or the power. Okay. So since e to the 2x plus 1, the thing we're trying to isolate, is multiplied by 3, we undo that but by dividing by 3. Okay. Whatever you do to one side, you have to do to the other. Okay. Your 3's are going to cancel out. Okay. You're going to be left with e to the 2x plus 1 on the left. Okay. And the right side is just going to become 5. Okay. So now that you have the exponential piece, the guy containing the base and the power, isolated by itself, you can go ahead and take the logarithm. Now, this is going to be one of the situations where you should use one of the logarithms over the other. Okay, remember, e and ln have a relationship. E to the x and ln of x are inverses of each other. Okay, they cancel each other out. So here, it is preferable to use natural log as opposed to log. Okay, you could use log. Your answer is going to be a little more complicated looking, but it's still going to give you the same answer at the end of the day. But the easier thing, because ln and e cancel each other out, easiest thing to do here is to use natural log. Okay, so in the next step, I'm going to take the natural log of both sides. So I'm going to get the natural log of e raised to the 2x plus 1 power is equal to the natural log of 5. Okay, all right, let me partition this off so we don't mix it up. I have a bad habit of writing close to the previous work, sorry. Okay, so here we go. All right, so remember, natural log of 5 is just a number, okay? You cannot get rid of this natural log now. It's there, okay? But on the left side, remember the property. If ln and e are side by side, they cancel out and the power comes down. So the left side is going to be 2x plus 1. X is out of the power, okay? The right side, the ln is still there. It doesn't cancel like it did on the left side. Okay, so you get 2x plus 1 is equal to the natural log of 5. Okay, natural log of 5, just a number. Okay, so x, you need to solve for it. So just isolate it. Okay, so here's what's got the x. You want to get it by itself. So first subtract off the 1. Okay, you're going to get 2x is equal to the natural log of 5. That quantity minus 1. Okay. And then if you want x, you need to divide both sides by 2. Okay, so I'll rewrite it just so it's clear if you're going back through this. So 2x is the natural log of 5, that quantity minus 1. Then you're going to divide both sides by 2. Okay, so x is going to be the natural log of 5, that decimal minus 1, all divided by 2. Okay, there's your exact answer. Okay. All right, so let's go ahead and put this in the calculator for our approximation. Okay, so be careful here. This is going to be the natural log of 5. That is all you're taking the logarithm of. So close the parentheses. Okay, then subtract the 1 because the 1 is not part of the logarithm. Okay, hit enter. This is the numerator. Hit the division key, then divide by 2. Okay, and there's your decimal approximation. So again, if we have to round to 3 decimal places, 304, look after the 4, there's a 7, so we're going to bump it up. So x is approximately 0.305, and that is your answer. Okay? All right, so this was our first example of where it was preferable to use ln because you had an e involved, okay? When is it going to be preferable to use log? Well, log in 10. So log of x and 10 to the x are inverses. So if you have an exponential of base 10, then it would be preferable to use log, okay? All right, next, example E. All right, so in example E, okay, here is our problem, okay? Again, when you look at this, you say, okay, this is exponential. The x is in the power. I've got to isolate the guy with the x, so that means the base and the exponent. Okay, so I'm going to put a box around it. The 5 is not raised to the power, okay? Just this is, okay? So we've got to get that by itself, okay? So you want to isolate it. All right, so to do this, let me rewrite the problem. We've got 1 minus 5 times e raised to the 1 minus x is equal to negative 7. Okay. First thing I'm going to do is move this number over. Okay. It is positive, so it's like adding it. So I'm going to subtract 1. Whatever you do to one side, you have to do to the other. So I'm going to do this as my first step of isolating the e to the 1 minus x. So the 1 and the minus 1 cancel. You'll be left with negative 5 times e to the 1 minus x power is equal to negative 8. Okay, on the other side of the equation. Hold on, let me get this thing to focus. All right, so then we almost have the e to the 1 minus x isolated. You have to isolate it before you take the logarithm, okay? So now what we're going to do is we're going to get rid of this negative 5. You have negative 5 times e to the 1 minus x. So if you want to undo that, you've got to divide both sides by negative 5, okay? All right, so the negative 5 divided by negative 5, those are going to cancel. You're going to get e to the 1 minus x on the left, okay? On the right, okay? Negative 8 divided by negative 5. The minus signs cancel here, so this is a positive 8/5, okay? All right, now this guy is isolated, which means we can apply the logarithm. Again, it is an e, so you're going to want to use ln here. If this had been 10, if you had 10 to the 1 minus x, then you would have wanted to use an log, okay? Again, at the end of the day, you can use either, but it is preferable to use ln in this situation, okay? So I'm going to take the natural log of both sides, okay? So again, what happens here, okay? ln and e are inverses of each other, and so since they're side by side, they cancel out, okay? And the power will come down, 1 minus x, okay? The x is out of the power, so that's great news. The natural log did not go away on the right side, so you have to keep it, okay? So the right side is the natural log of the fraction 8/5. It is going to be some crazy decimal, okay? So now we need to isolate the x, okay? So we got to free it up. All right, so this is 1 minus x. The 1 is positive, so we're going to subtract the 1 off, okay? So in our next step, we're going to get that negative x is equal to the natural log of 8/5, that quantity, minus 1, okay? And then if you want x by itself, x is being multiplied by negative 1, so you need to either divide off the negative 1 or multiply both sides by negative 1, okay? So it's going to look like this. Okay, so negative divided by negative is positive, so x is going to be, well, okay, you got this thing on the right. Okay, you're dividing by negative 1, so remember, if you divide by negative 1, it is going to change the sign of everything. Natural log of 8/5 is just a number, okay? So if you divide it by negative 1, the negative sign will go out front, like that. And then negative 1 divided by negative 1 is positive 1. Okay, so here is the exact answer. By dividing both terms in the numerator by -1, you got rid of the fraction. Okay, so there you go. Like I said, that's the exact answer. We've got to punch it in to get a decimal approximation. Okay, so be careful here. You want to do negative natural log of 8/5. The entire 8/5 goes in parentheses, and then add 1. Okay, so that's how you enter it in. Hit the equal sign, round to 3 places. Okay, so we've got 529, and then a 9 after it. This 9 will bump it up, so it's going to be 0.530 is our approximation. So x is approximately 0.530. Okay. All right. Let's do one more, part F.